Hey guys, and welcome back to my shop. So if you're thinking, didn't we already take a look at one of these Creality Falcon 2 Pro laser cutters earlier in the year? Yes. Yes, we did. However, Creality has raised the spice level on these up to maximum. Let me get this open, I'll show you what I mean. So Creality has somehow squeezed 60 watts of power into their latest laser module. And for comparison, the previous one we took a look at was 22 watts. Now that is an insane amount of power to have in a single module. And honestly, it is pretty big. And I'm interested to see how that affects the performance of this overall, since I think everything else in here is identical to the one that we already took a look at. Although I am interested to see if they took any of the feedback from the community for their first release of this and fixed some of the simple problems that we were all complaining about. More on that later, but I went up to their website to understand how it is that they managed to get 60 watts into a single module. And the reason why it's grown larger is because what they've done is they've added a bunch of additional laser diode modules in here, and then they're optically combining them. Now there's pros and cons to that, and we'll talk more about that later in the video as well. But for now, let me get everything out of the box, get put together, and I'll bring you guys back. All right, guys, I finished the assembly on this last night. I figured we'd wait until today to keep going on it so we have a bit more natural light here in the shop. And I did want to point out the product manual, which has the assembly instructions for this from Creality, is genuinely really good. There's pictures in here for everything, and it's super easy to follow. I've bought equipment like this before, where it looks like it's just a single sheet of paper that somebody wrote out a rough set of instructions in Chinese or another language and then Google translated them into English and printed it out. This is nothing like that. The instructions in here are really, really well written, and it's step by step, super easy to follow. So thanks, Creality. And just look at the chunkin' power supply that comes with this machine. This is 15 amps at 24 volts, which is an impressive amount of power out of a power brick like this. The one that comes with the 22 watt version of this machine is substantially smaller. It's nice to see that they didn't skimp on that. All right, I do want to take just a minute and talk about laser safety, because I think a lot of people looking at these machines, trying to decide which one to buy for their first machine, do not understand how dangerous a laser cutter engraver can be. It is easily the most dangerous machine in any shop. Yes, more dangerous than a table saw, even more dangerous than a metal lathe. And the reason I say that is because just the scattered light that comes off of whatever you're cutting is enough to blind you. And I don't mean temporarily, I mean for life. So even if you always remember to put your safety glasses on every single time, do you lock all the doors coming into that room? Like, what if someone else comes in? That's why I would never look at a laser cutter engraver that is open frame unless you have a very specific use case for that and you can't use an enclosed machine like this one. And as far as enclosed machines, I do think that this is the one to beat right now. Creality has done a great job designing all of the safety features and the enclosure on this machine. From opening the door, you see keep an eye on this blue light here. There's actually one on each side. As I open this up, instantly that changes. It knows that I've opened the door, and if we were running the laser right now, it cuts off instantly. And I do mean instantly. And once this is closed, you could walk around this machine 360 degrees, and there's no angle that you could peer in there without looking through the acrylic material that is filtering that scattered radiation coming back up off of the laser. Now, if you want to consider my opinion biased, that's fine. Go ahead. I mean, Creality did send this machine out to me free of charge. They're not paying me anything for this review, and they have no control over what I'm saying in this review video. But they're not stupid. They know if they send their machines out to creators, those creators are going to use those machines on their channel, and that exposure is good for them. But I can tell you guys, after having used the 22 watt version of this machine for about 6 months now, if I had to go out and buy one of these machines with my own money, it would absolutely be one of these Falcon 2 Pro machines, at least for now. I mean, competition is a great thing. Other machines might come along that are even better, but right now, from a features and safety perspective, this is the machine to beat. Oh, and another quick note on safety, when you're cutting and engraving, it generates a lot of smoke and you really shouldn't be breathing that. Creality provides this machine with a fan and an exhaust tube, and if you're near a window and you can drop that out of a window, awesome, you're good to go. If you're not near a window, get yourself a fume extractor. I don't have a window anywhere near where I have this machine sitting right now in my shop, so I connected it to a fume extractor that I already had from another setup. So consider that. If you can set up near a window, you're probably fine. If you can't, make sure you get yourself a fume extractor as well. So when I got this machine together, one of the first things I did was compare it to my 22-watt machine to see if they resolved either one of the two gripes that I had with the 22-watt version of this machine. And the first one was around the air assist. And if you're not familiar, air assist on a laser cutter like this, or laser cutter engraver, serves a couple different purposes. This is just a small air compressor that's just provided with the machine. And this tube runs that compressed air into the machine, and it's actually routed over to the laser head, and it shoots right down through the center, the same place where the actual laser light comes out to do the cutting. And that keeps your surfaces much cleaner when you're doing engraving, and it also aids in cutting because it blasts any of the material that has been cut down through the cut rather than letting it just accumulate and making a mess in that cut. But my gripe was, they put a wheel here to control the airflow on the machine, and it's not pinching off the tube. I originally thought, oh, it probably just pinches off this tube as you rotate the wheel. No, it's a digital control, and they had said that there was a way to control the airflow via G-code in the software. I couldn't find a way to do it before. I noticed on this one, they've added a sticker here, and it refers to a user manual for airflow adjustment. Sure enough, I checked out the CF card that they sent with this, and lo and behold, they've added a document that explains the syntax of the codes to send to control the amount of airflow that comes out of the air assist right in your settings in Lightburn, which is awesome. Thanks, Creality. The other gripe I had with the 22-watt version of the machine when I reviewed it was the cabling that Creality provides. So they provided two of these USB-C cables. This one provides connectivity to the machine itself and is low down here on the body and also right where the thick power cable connects. The other cable plugs up here for the camera. There's a camera on the underside of this center section here that looks down into the chamber. And they provided another one of the same USB-C cables, and unfortunately they're still doing that with these machines. You can see I've already substituted my own right angle cable. I don't understand why they don't just ship this machine with a right angle cable. Now, all that aside, this is like a $5 fix. I don't even know if this cable costs that much. I'll link to the specific one that I bought down in the description of this video, but it's a small gripe. But I mean, come on, a right angle cable is way better there than one that is sticking way out and then, you know, routing either up, down, or wherever. That thing's gonna get knocked into and it's gonna get broken off. And speaking of cameras, that's actually the next step for us to do here in our setup process of this machine, is to use the included lightburn calibration card to fully calibrate that camera so that we can trust that whatever we see on the screen when we're setting up our cuts is where we're actually going to cut on the material. That's one of the huge selling points of this machine, is that it has a camera built in. If I angle this in here, I think you guys can probably see it. Now, the way that calibration works is we just move this calibration card around to whatever point on the bed the wizard is telling us to do. It takes a picture of these dots and it understands then where there's distortion from that camera lens and corrects for it so that we get a perfectly square and aligned image in here. Now, I was about to do this and I realized that sitting on this workbench, this machine is not actually level. I know this workbench, it's warped over the years, and I know it's not quite flat, and I'm noticing that I can actually sort of lift up on the corner of this machine, which is flexing the whole chassis. So I'm worried if I do the calibration out here on my workbench that it's going to end up being off and I'm going to have to do it again. So I think I'm going to go ahead and move this machine to where it's actually going to live in my basement. It's not going to be as easy to shoot down there, but I'll know that when we do that calibration that everything is true and genuinely square and I won't have to run it again. So I'm going to move this down to my basement. I'm going to run through that calibration and I will bring you guys back. All right, I have finished the calibration for the camera and we can see the view here now inside of Lightburn. So the small window here on the right, this is actually the live view inside the Falcon 2 Pro. And in fact, I can actually steer the laser around inside the machine here. And if we hit home, you'll see that go home and sort of get out of the way so we can see this piece of material in here. And this is why you have to go through the camera calibration. If you look at this live view, you can see the curvature in the image. There's a fisheye lens in here that allows us to see the entire inside of the machine, even though the camera is not that high off the bed. And if we look at our view here in our setup area in Lightburn, you can see that actually that material looks quite square. And if I hit update overlay, this is not a live view here. You do have to hit update overlay for it to update the image, but it's taking that image from the camera and it is adjusting it to be square and taking out all of the distortion from that fisheye lens so that we can actually use this view to align our work. Now this is super important because this is one of the really challenging things to do on a laser is if you're trying to engrave on something that already exists, like maybe you have, I don't know, like a wooden keychain or, you know, even a piece of anodized aluminum or something like that, that you want to have a design in a specific spot, it can be really, really difficult to align that. But because we can see a view of the actual material sitting in the bed, we can choose exactly where we're going to do either that cutting or engraving. And another good application of that is exactly what I have here. This is a piece of material that's left over from a previous project on my 22-watt machine. Now, I tend to not throw these away. I collect more of them than I probably should because there's still material here that we can use. But it's such a pain to use this type of material when, again, you don't know where you're actually going to be cutting and engraving on. So it's easier to just throw it out. In this case, let's just say I want to, I don't know, maybe cut out a square here. I want to have a small circle cut out here. I want to have another square down here. Actually, we'll make this like a nice long rectangle and all of the available space that we have there. And let's see, we'll have another oblong circle here. Put a square here. So you see we can use all of the available portions of this material. In fact, you know what, let's put like another long one all the way down the side over here. We'll get really close to the edges. We'll see just how accurate this is, because that's the other thing too. The further you get away from the center, the more distortion that you're going to have, that it can't 100% clear up in software. We can see down here, there is a slight difference in sort of where these corners sit to this grid line relative to the top. So, all right, I'm going to actually go ahead and cut these shapes out and we'll see just how close we got to where we laid them out. Okay, looks like all those cuts are complete. So if we update our overlay, we should actually now be able to see those cuts here and we can compare to where our lines are. So it's a little bit tough to see them, which means they're probably right underneath where we actually drew our shapes. So let's go ahead and make sure these are all selected. Let's delete them. And yeah, look at that. It was right underneath where we drew all those lines here. If I undo that, put them back on, you can see we are really, really close. There is maybe, I don't know, half a millimeter to a millimeter of offset there. Same thing here. This one looks like there's maybe, well, not really. I don't know. I think that just might actually be the shadow of where the light is coming from inside this machine. These are all pretty much dead on. All right, these cuts all came out really clean. Looks like I was going a little bit too fast because this one, I'm just having to push on it a little bit to pop it out. But yeah, those are right where we placed them. All right, well, that was a fun test, but I have a real project that I'd like to do that I think is also going to really test the limits of what this machine will do. Let me show you. Okay, so we're up here in my barn, and apologies for the sound of the generator running in the background. This building is not wired into the grid, so if the generator's not running, we don't have any lights, and it gets pretty dark in here. So here's the problem. I have a bunch of sheet goods stored at the end of my pallet racking. I have pallet racking all along the back of the barn, and I have an extra upright, and I positioned it here at the end, figuring that I would find a way of attaching this last upright to this one, so that I could safely store sheet goods here in the middle. Well, you see how that plan worked out. I never actually figured that out, and I started storing sheet goods here. That was 2 years ago, so I should probably solve this because I've had a couple close calls where I'm trying to slide material in or pull material out, and it's all started to fall this way and almost knocked this guy over. If we can successfully tie the top of this upright to this upright, imagine like something that comes up and connects these two together, then I can also lean sheet goods on this side without the fear of everything falling over. Because right now this guy is just standing up. It's got pretty wide feet, so it does stand on its own. But otherwise, yeah, it's gonna fall over. Okay, so from the top of the pallet racks, I think it's a little easier to see the challenges here. If the uprights were taller than the material, we could just simply run like a 2x4 between the tops of the two and call it a day. But because they're slightly shorter, or because our material is a little bit longer than the 8-foot uprights, we need to come up, go across, and then go back down. And we need to think about force not only pulling these two apart, because if I was to push all of this material in that direction, right now I would just knock that upright over. But if they're tied together, all that force is going to be pulling between the two. We also need to think about the force that is going to be pushing this upright in this direction if we lean sheet goods up against the other side of it. And we want to do the same thing here for the back. So we need to, whatever we need to make 2 of them. Now, I don't even need to measure to know that these are more than 400 millimeters apart, which is the maximum size of material we can cut, but that's okay. This is going to be strongest not only if we use plywood, but if we use multiple pieces of plywood tied together with glue and screws. So I think what I'm going to do is get a number of measurements. We need the distance, say, between, at a minimum, like between this face and that outer face. We need the dimensions of this box structure. And I need to figure out how much further we need to come up from the top face here to clear material so that we can easily get material slid in and out of here. So, all right, I'm going to go grab my tape measure. We'll get all the measurements we need, and I'm going to draw something up, and I'll bring you guys back. All right, and after taking a bunch of measurements and doing a bit of head scratching, here is the design that I came up with for this. And it's going to be 3 layers of plywood thick, and then of course each piece of plywood itself is made up of a bunch of laminated layers. So this should end up being really, really strong. And the way I designed this is the top layer is going to have these sort of, let's call it short sides, a long center section, and then of course another short side. The layer underneath that will have a long side, so this is one piece that's going to come all the way over to the center. Same thing on this side. And then the bottom layer will be another one of the short side pieces, a long center and another short side. And you can see I've already peeled off those layers so I can grab the DXFs that I need to go ahead and pull these into lightburn and cut all these up. I've also gone ahead and integrated all of the holes in these for screws, and I did that not just so I don't actually have to drill the holes, but that should help align everything when we go to actually assemble this guy as well. You can see here I've got some notches. This is designed to hold this up off of the top of that upright so that we have clearance for those tall pieces of wood. This is 20 millimeters of additional rise here, and then the whole thing is an arch, so we'll be even substantially higher in the center of this if we do have any longer sheets of material. So, all right, I'm gonna go see if I can find some material that we can actually cut this up from, and I'll bring it back. Okay, I found a piece of material in here that had already been cut down. It is still the full 4 feet this direction, but it's not 8 feet in this direction. And I just roughly gridded it out into 16-inch by 16-inch squares, which is a little over 400 millimeters, hence the maximum size that we're gonna get into that machine to cut anyway. And that leaves us with some much smaller ones at the bottom, but that's okay. I think that'll work for some of the parts that we need as well. So I'm gonna drag this outside and cut this up. All right, I've been running tests for quite some time on that material that we just chopped up to figure out what the best settings for laser cutting it are. And let me tell you, we are pretty much right at the limits of what that machine will do. This is 20 millimeter thick hardwood plywood. So it's just about the most difficult material to cut. If this was a softer material and it was even thicker, we could probably cut it. But for hardwood, I think 20 millimeters is going to be the limit. And that limit comes not just from the wattage of the laser. I think if this machine was any higher watts, I don't know that it would really make a difference. What happens is when you're cutting material that's fairly dense like this, the further away the bottom of the material is from the laser module, the harder it is to cut because that beam expands. So when you're cutting thin material, think about it, you're dropping the laser. So imagine we're cutting this material down here underneath my thumbnail. We would bring the laser module down to just above that and make the cut, right? But in this case, to cut through this material down at the bottom, the laser module is still all the way up here now where this thumb is. So by the time that beam gets all the way down to here, it has widened a bit. And it's not crazy wide. It's not like a giant cone shape. But even if it gets just 50% wider, that's 50% less power, essentially, or really not less power. The 60 watts of power is still there, but it's distributed across a larger surface area, so it's harder to cut thick material because of that beam width essentially going out of focus the deeper the material you're trying to cut is. Now, I was able to get through this with a number of different settings, and in fact, it'll cut through this in, if I go slow enough, in just one pass. But the cut's not very clean. There's quite a bit of charring in the cut, and that's what a lot of these rectangles are, is me trying to just narrow in what is the best settings, going a little bit slower with 1 or 2 passes, or speeding up a bit and doing 3 passes. And ultimately what I discovered for 20 millimeter hardwood plywood, this is the sweet spot, is doing 3 passes, 100% power at 275 millimeters per minute. It actually makes it through. So this one was cut with those settings. This one here was cut with the same settings, but just 2 passes. And you can see it almost makes it through in 2 passes. But because the beam is so out of focus by the time we get through 20 millimeters of material, it needs that 3rd pass to get all the way through. And in fact, this test cut up here is those same settings again with only 2 passes. And if I'd done 1 more pass with that, we would have made it through for the test shape here. So, all right, now that I know what settings to use, I'm going to swap in all of the pieces of material that we cut for this project. We'll get all of the different shapes that we need cut out, and we'll get this put together. All right, all of our pieces are cut, and I'm really impressed with how these came out. If we look at these cuts from the side profile, you can see it is pretty clean. As we get down to the bottom part of the cut, that is where we do see more charring, and it varies a bit depending on, I think, the density of wood. Like if we look over here, I can see more charring there, but it is still a pretty square edge. But look how clean it is at the top. I think you could see, even on hardwood plywood, if this was, I don't know, I would say it goes through the first 3 layers here really, really clean. There's hardly any black there at all. I think, in fact, even the black that's there, I think is probably from the lower part of this cut as that beam widens up, and a lot of that is just kind of shooting back up through the cut till it makes it all the way down through. But they're all done. I'm gonna move you guys out of the way so I can stand where you are. We'll get these glued up and see if this fits. All right, that's all together, and honestly that was kind of fun because with those screw holes already integrated into the pieces, putting the screws in just lined everything up. I did make one mistake. I don't know if you guys caught it. I'll probably speed the footage up. The bottommost piece here, when the screw went in, I missed the hole and it was sticking out. It was super obvious. I just backed the screw out, pushed it over, put the screw back in, and it just pulled it right back into alignment. So that actually worked out pretty well. The glue says 24 hours, so I'm going to assemble the other one of these off camera, and then I'll bring you guys back tomorrow when these are set up and we'll go test them. All right, and while we're waiting for those to dry, now's a great time to talk about the different trade-offs that you have by having such a powerful laser module in one of these machines, because there are some trade-offs. I talked about earlier how they get to 60 watts, and that is by having different diodes inside that laser module and then combining the beam. So I tried to think of a way that we could easily compare the differences at the different power settings for this machine, because in addition to being able to set the laser from anywhere between 0 and 100% in software when we run G-code, Creality has actually given us control over the power output of this machine. They know there's that trade-off on the beam size. So right on the top of the laser module, there's a button you can press that actually, you can set it from precise to normal to full power. And what I did is I took 3 different cuts in a piece of material at those different power settings, the 22 watt, 40 watt, and 60 watt, so we could compare just how much wider the beam essentially gets on a 60 watt module. And here is that piece of wood that I ran the test on, and this picture is taken under a digital microscope, and honestly at this magnification it's hard to see the difference between the 22 watt and the 60 watt, particularly with the 40 watt there in the middle. But if we magnify even further and I get rid of the 40 watt line and we compare just the 22 watt line and the 60 watt line, you can see a difference in the 60 watt line. And in fact, I measured the pixels in Photoshop since these are taken at the same magnification level, so we can directly compare. And it's about a 26% difference, which I'll admit is a lot smaller than I thought. I thought we were going to see at the 60 watt setting a beam size that was, I don't know, 50% larger, but yeah, it actually measures out to be about 26% larger. Now that 26% difference is really not going to make that big of a deal when you're cutting material. In fact, you can even adjust the kerf size in lightburn to accommodate for that. But if you're engraving an image, particularly into a piece of wood or into some material, the thinner the line, the better, because that's essentially your resolution, right? The smaller the line that you can draw on the material, or the smaller a section of material that you can shade, is going to give you a higher resolution engraving. And Creality knows that, and they've actually included an entire separate laser module, a 1.6 watt laser module that is going to give you a much finer line so that you get the greatest detail when you're engraving with this machine. All right, it's been 24 hours. These should be all set to go. And while I was waiting for them to dry, I also 3D printed up some spacer pieces here, because the uprights that these are going to slot into, if you recall, were square shaped. There was about 70 millimeters square. If we had gone with another piece of material here, this would have been too thick. So I designed and just quickly 3D printed 4 of these pieces that we can screw. I'll actually screw these to the back of these, but this fills out that gap so it's not wobbling around in there. All right, I've got you guys on a precarious stack of stuff because this is 8 foot up in the air, so hopefully the tripod doesn't fall over. I'm gonna try and put the front one in first. I did bring a mallet with me because I'm assuming these are gonna need some amount of persuasion. I did design them to be a pretty tight fit in here, as I don't want this to rock around. Wow, that actually went in really well, and it is snug. Let me climb up here and see if I can get the back one in. Well guys, I think that's job done. I can't believe how easily both of these went in. Looks like we were dead on with our measurements. Both of them just required a little bit of a knock with the mallet to drop all the way down, and they are snug. It does not move around at all. Yeah, I'm really happy with how that looks, and more importantly, I know I can confidently come in here now and lean sheet goods up on either side without fear of everything toppling over. And I'll probably come back and put some stuff on the outside here now as well. Honestly, it looks pretty good too. I kind of wish I had engraved something on the front of that. That would have looked cool. Well, I think that pretty much brings us to the end of taking a look at the Creality Falcon 2 Pro 60 watt laser cutter and engraver. There's so many cool things you can do with this machine, and here on the bench is just some other samples of stuff that I've done with it. This is Fel-Pro gasket material. You can actually design and cut your own gaskets. This is adhesive backed cork, and I put the 1.6 watt engraving module on and I tried out engraving. And the detail that you get with that is significantly higher with the 1.6 watt module. And because this is so much lighter, it can run a lot faster in the machine as well. And thanks for hanging out in the shop with me here while we got this machine put together, calibrated, and really put it through its paces doing some actual functional work. And that's the focus of what I do here on the channel. It's all functional making, mostly 3D printing, but I also do some laser cutting, work with a milling machine and the lathe as well. If after watching this video you want to pick one of these machines up for your shop so you can do some of this stuff as well, take a look down in the description of this video. There's going to be a discount code and a special link. Copy the discount code and then click on the special link. It'll take you to a page where you can plug that discount code in and you'll get some extra money off as a thank you for making it all the way to the end of this video. And as always guys, thanks for watching, and I'll catch you on the next one.